So let's now explain the code. Okay. So first, it's on the option explicit. What is option explicit? This command, actually, this is to force us to declare the variables, so that if there are misspelled variables or undeclared variables, then the our VBA will notify us of an error, notify us of the error. So by that, we will know that we have had undeclared variables. Because if you don't use option explicit, then even if there will be undefined variables, then we won't be notified, because it will assume a data type of variant. That is, any undeclared variable, it will assume as a variant. And for example, let's say just like the mistake that I had earlier, if I won't use option explicit, if I won't include this one in the code, so instead of CD, I will use C. For example, here in this part. So instead of CD, I mistakenly type C. Since C here does not have any value, so it will assume a value of 0. Now, therefore, the CD here, which is supposed to be 2, will have the value of 0. It should be sent to the CD here, another function dy. So that would mean g minus cd over n times v is will return the value g. So I'll have erratic values. So I'll have wrong answers. And I won't be notified with that, because if there's no option explicit, it would be fine for our code that we introduce another variable, if we introduce undeclared variables. However, if I use option explicit, every variable has to be declared. That's why if this was just C, when we run this code, it will notify us that the C is undeclared. So by that, we will know that this is supposed to be CD. So that's for option explicit. Now for the function Euler, I suppose that you already had your basic programming. This is actually a part of modular programming, wherein we create functions or a set of isolated procedures, or we can also say modules, which we can just call and do analytic to its function. So for that, we have created this function Euler. This function Euler, maybe we can also observe this one. This will now be available. Let's see, it's the function Euler. Okay. Anyway. then then after this, so in creating a function, there's this word function, then the name of your function, then the arguments to that function. The arguments, there can be arguments in a function. There can be or the function can have no arguments at all. It depends on what you want to do. But in this case, the Euler function, it has inputs, so that's why it has this argument. Now, after that, we need to declare the variables that we'll be using by using this word command dim. Then the variable name, as we declare it as double. Double, this is y double, so that because double can represent more numbers with more decimal places, so that's why we are using double. But you can try to use single and see the difference. And this is actually a data type, so you can just look for the data type. Now, if ever you have any question for this, you can just access the help. Okay, then from there you will have tons of information. Then we declare the age, we declare the t, the y, the dy dt, all of them as double. Then you make the assignment, that is t is equal to our input ti, y our input yi, h our step size to our input dt. Now this one, the do loop, I'm sorry. Now this means that our program will do this for a number of times until it will exit the do loop. When will it exit this loop? It's when t is greater than equal to tf. If this is true, then the program exits the do loop. Now, what's within this? This basically, it's actually the main part of this is this one. This is, as what I've said, this is the this one. Now we know that we need to, for every iteration, the y will be updated. This is the vi plus 1. This will be the vi. This is the dvi dt times h. Now h will take different values, right? So that's why t is equal to t plus h in order to increment. And okay, let's have the first iteration. During the first iteration, it enters here. If t, that is t is 0, the first iteration, ti here is 0. For this cell, ti is a8, this one, tf is this one, and yi is this one. Therefore, during the first iteration, so it's 0 plus dt is 2. So 2 is this greater than tf? That is this greater than 2? No. So it will not enter this portion. it will jump here, and dy dt is equal to dy mcd. This is actually the name of this function. Therefore, this part is actually calling this one with this as its inputs. So it will be here. P, y will be equal to v, v will be equal to y. This m will be equal to this m, cd will be equal to this cd. So by this function has defined a constant variable g as double, which is equal to 9.8. Then dy will be equal to g minus cd over m times v. This is actually the slope. If you can remember this one is actually this one. So this is the slope dy. Therefore, this should be updated with a value equal to this one when evaluated. So this will be the value of this one will be assigned to dy dt. Therefore, during this time, since G, C, D, and V, since V initially here is equal to 0, so this will just be 9.8. So that's why here it will be y, which is initially 0, which is 0 at this iteration, so 0 plus dy dt is 9.8 times h. H is dt, which is equal to 2. And that's why there's 19.6. So y is equal to 19.6. Then t is equal to t plus h. That is, this t is equal to 0 plus h. That is 2. So 2 will be then assigned to t, thereby updating t. Now, if t is greater than equal to tf, that is 2 is greater than or equal to 2. Yes, it's true. Then exit. That is, it will exit this do loop. This do loop. After it exits, y here from here is actually 19.6. It will be assigned to Euler, which is our function. So this will be the output 19.6 will be sent to our B9, to our cell B9 as its value. So when we now come to B10, this will be its TI, this will be its TF, it will be its YI. And the same happens again here. For B11, still the same, up to we go to here. Now, what's the use of this part? Now, there are times, it's for this example, this won't be usable because t plus dt won't be greater than tf because the dt is equal to 2 and the intervals is also equal to 2. However, there are times in which the tf minus ti over the interval is not even, by which because of which, when you come to the last iteration, t plus dt will be higher than tf, that is. But you have to take note that we are just calculating the velocity up to the final, up to tf. So that's why if our time will be greater than tf, then that's already out of range. So that's why there is this if statement. What it does is, if it tests first if t plus the step size is over or goes over tf, and if it does, then the the step size, will be updated to tf minus t, so that when this h will be added here, it will be, when t plus h will be added, the result will be exactly at tf, so that during the last iteration, so this will be for, maybe I said it wrong. This is for the second to the last iteration, so that the t equal to t plus h will fall. This one will fall exactly at tf for the during the final iteration. Okay. Now, what other else? Okay. Okay, let's go to spreadsheet. So now let's have a graphical representation of these values. For that, let's highlight this one, vnum and vanal. Go to insert, then click insert line or area chart, and choose this one. Let's change our title to parachutist velocity. This one, then this one should be the time here. So let's change this. Should be this one. Okay. Okay. It has now been changed. Then let's also have axis titles. So before time in seconds. This is for velocity. Meter per seconds. Meter per second. Okay. Now, let's try to change this one. Okay. In the previous lecture, it was mentioned that the smaller the step size, the more accurate our results will be. So what if, let's say, we'll have 2 from 1. What happens? So as you can see, approximate values are now closer to the true value. Okay, so actually what happened if since we have the step size from here to here, it took 2 iterations. It's from 0 to 1, then 1 to 2. Previously, it's just from 0 to 2. Then also with this one, it also took 2 iterations from here to here. Now, what if we have 0.1? Oops. Okay. Okay, so that would be, as you can see, it's almost the same with the analytical values. So from using a step size of 0.1 from here to here, it took 2 minus 0 over 0.1, that is 20 iterations. In the VBA, here in the loop, it actually took 20 iterations for Excel to have these values. It took 20 iterations. So also that is 1. 4 minus 2 over 0.1 is still 20. So to have this value, it actually has gone through 20 iterations here. For this part, let's say it's 0.3. It's 0.3. So start change right 4760. It's 4783. Okay, so for this one, 2 divided by 2 minus 0 divided by 0.3, that is 6 point something, 6.67. So that at the 6th iteration, when he had t plus t, that is 6 plus dt. dt here is it's 0.3, so it will be point from 1.8, that is t equal to 1.8 plus 0.3, it will be 2.1. It's greater than tf, which is equal to 2. So that's why it's tf, that is 2 minus t, that is 1.8, it's 2. So h, instead of being 3 up 0.3, it will be just 0.2. So that when you have it here, it will just be it will be exactly 2. Okay, So you can also play with this one. What happens if the mass is 200 kilograms? So to reach it will have a steeper graph. Which means it increases, the velocity increases much faster than the terminal velocity will be at 156, so it's still very far. So that's why we haven't seen the curve yet. Okay, so you can experiment and do it on your own. No, it's 2. Okay, so next to this would be the MATLAB.